So let's just move on further and talk about the non-Euclidean geometry. Yes, the non-Euclidean geometry. So let's just talk about the Euclid first. As Euclid did not require his fifth postulate to prove his first 28 theorems. Moreover, Euclid and other mathematicians considered the fifth postulate as nothing but the theorem which can be proved using the four postulates and other axioms. But actually, the whole attempts that are made by them to prove the Euclid fifth postulate using the four postulates and other axiom were failed. Yes, they were failed, but it led to the discovery of various other geometries as well, and those geometries were actually a landmark in the history of thought because they are called as the non-Euclidean geometry. And before the invention of the non-Euclidean geometry, the whole world thinks of having the only geometry in the world as the Euclidean one, or the world is nothing but Euclidean itself. But after the invention of the non-Euclidean geometry, the whole world actually changes, and now the geometry of universe we live in has been shown to be a non-Euclidean geometry. So this is nothing but a special note which is related with the non-Euclidean geometry, and it is also called as a spherical geometry. So non-Euclidean geometry is also called as a spherical geometry. So in spherical geometry, always remember the lines are not straight. They are the parts of the great circles. So what are the great circles? The great circles means actually a circle which is formed by the intersection of the spheres in which a plane is actually passing through their centers. So this is nothing but a great circle. So let us suppose if we have this particular figure. So from this figure, what we can say about it, as we can see, we have AN and BN, which are nothing but the perpendicular, which are the perpendicular lines, and they are nothing but perpendicular to the same line which is nothing but AB. Moreover, they are forming an angle of 90 degree over here. They are forming an angle of 90 degree over here as well. So as you can see, if this is 90, if this is 90, 90 plus 90 is nothing but is equal to 180 degree. But if their angle is 180 degree, then again they are meeting each other at this particular point. And moreover, we can say that if this is nothing but a triangle, that is ABN, if it is a triangle, then the sum of the interior angles over here is definitely greater than 180 degree. So from this particular figure, what we can conclude? We can conclude that if we are looking at this particular figure, the lines AN and BN are perpendicular to the same line AB such that the sum of their angles is nothing but 180 degree, and they both are intersecting each other at the point N. Moreover, the sum of their angles in the triangle A and B is definitely greater than 180 degrees. So from these particular things, we can conclude that what we can conclude, the Euclidean geometry is valid for the figures in the plane only. On the curved surfaces like these, it definitely fails. So it definitely fails. As you can see from this particular figure, we can say that the Euclidean geometry is valid only for the figures that are lying in the plane. On the curved surfaces, it fails. So this is all about the non-Euclidean geometry.